Good afternoon. I'm going to take a few moments to kind of review linear regression analysis. Wanted to do that for those of you working on your Connect homework. It associates with the second problem that is currently in the Connect homework associated with problem 3-12, and I think that should be a heading you would see on that problem. But just as a reminder, regression is used to identify a functional relationship between two or more correlated variables, usually from some type of observed data. One variable, the dependent variable, is predicted for given values of the other variable, which we call the independent variable. And so, this should be repeat of what you've seen before, but linear regression assumes that the relationship can be explained with a straight line, and the formula for that straight line is y equals a plus bt, where y is the dependent variable value, a is the y-intercept of the line, b is the slope of the line, and t is the index for that particular time period. Okay, so when we look at an example of linear regression, right, we might look at sales over quarter, right? So we have 12 quarters listed here and the sales quantity for each quarter. And when we use the least squares method of linear regression, it determines the parameters a and b such that the sum of the squared errors is minimized, and that's therefore why we call it the least squares method. And so basically you're trying to fit the line between the data points so the squared error variance is minimized. Okay, and so I'll show you a calculation here as they do it in the textbook, and then we'll actually do an example in Excel to give you a good comparison and a good review. Okay, one of the first things we have to remember are what each of these variables represent. Okay, and t is the value for time, right? So we're talking about quarters. So here's quarter 1, 2, 3 through 12. Y is the actual value that was observed at that time period. So our demand for each of those quarters is listed here. Okay, for part of the calculations, we're going to need the sum of t times y. So 1 times 600, 600, 2 times 15, 50, 30, 100, etc. We're going to square t, and we're going to square y, right? And then we're going to use that information to then predict what we think what our linear equation would have said it should be. Okay, so again, our formula for our straight line is y is equal to a plus bt, where b is the slope of that line. And so to determine the slope, we're going to take the sum of the ty's, right? So here's t times y. We're going to sum those up, and that's 268,200. And we're going to subtract from that the number of time periods, which is 12, times the average of those time periods. So if I take the average, 78 divided by 12 is going to be 6.5, and I'm going to take that times the average y value. So again, I'm going to sum this up. It was 33,350. If I divide that by 12 time periods, that's going to give me the average, which is 2,779.2. My denominator is going to be the sum of the t squareds, right? So I'm going to add up all of these. That's going to give me 650 minus the number of time periods, which is 12, times my t squared, right? And so my t squared is going to be 6.5 squared. And I think that should be the average. So you can just barely see that average sign right there. That means the average of that. So here's our t squareds, and we're taking the average of that. So 650, right, divided by 12 is going to give us the 6.5. Okay. Okay, so we finished that calculation. We understand that B is 359.6. I want to clarify. At first I was thinking that this was the average t squared. Okay, so I was going to take 650 divided by 12, but really what it is it's the sum of the t's divided by 12 to get the average of 6.5, and then we square that. So make sure that you're clear on that, that this average t squared, we're taking the average of t and then squaring it. It doesn't have anything to do with that t squared column. All right, so then I can calculate A, and A is the y-intercept, and A is going to be average y minus the slope times the time period. Okay, and so so average y, right? We've summed up the y, so 33,350. We divide those by 12. That's 2,779.2 minus our slope, which we calculated at 359.6, times our average t, which we said was 78 divided by 12 is 6.5. We finish that calculation, it's 441.67. So then when I go to estimate the demand for time period 1, it becomes A plus B times T, which is our A, again, is our y-intercept of 441.67, and that doesn't change across our time periods, plus the slope, which is 359.6, and again, it doesn't change across the time periods. But we take the slope times the time period, finish out that calculation, and we know that our forecast for time period 1 is 801.3, time period 2, 1160.9, etc. Okay? And so we were able to calculate that on known data, and then we're able to extend that into time periods coming up that we don't know. So then we do time period 13, 14, 15, 16, just the same way that we did time periods 1 and 2. And so once we get the slope and the y-intercept, right, it becomes relatively easy then to calculate, all right? But it takes a little bit to develop this table. And you're going to need to know, for how to do the problems, you're going to need to be able to develop the table, and then I'll show you also how to do it in Excel, so you can kind of check your work if you'd like to do that. And then on the exam, I won't ask you to do anything maybe quite this complex, but you'll have to have an understanding of how it works. Okay? And so regression with Excel, Microsoft Excel includes data analysis tools which can perform least squares regression on a data set. So here's again our data set, and we would go and do regression, and again I'll show you how to do this on a problem, input the Y range, input the X range, indicate the labels, and identify where we want the output range to be. Okay, and then here's the output that we're going to receive. Okay, and so that's going to tell us that our intercept is 441.67 and that our slope is 359.61. Okay, so that should be very consistent with what we saw on the previous page. All right, so let's go ahead and move then to connect. And I'm going to put you on pause while I bring up Connect. Okay, so here's the problem 312, which is the second part of the Chapter 3 homework. And again, I'm going to go ahead and copy this into an Excel file. And we'll do this kind of the long way first, and then we'll come back and do it using Excel. So I want to again format these to be numbers. So format cells number, and we'll go with 2 decimal places. Didn't seem to take that. Let's go format cells number 2 decimal places. There. I may have to just, in this case, retype over them. And because I retyped them, I'll just take a quick second to double check them. 4130, 4230, 3930, 4330, 4930, 4630, 5230, 4830, 5330, 5630, 6230, and 5930. Okay, so it looks like we have the numbers right. Okay, so that being said, I'm going to insert a column here, and I'm going to say that this is time period 1, 2, 3, 4, and just extend this on down for the 12 months. Okay. So that's my T value, right? And then these units are my Y value. And my next column then is T times Y, right? And so if I need to do that, decimal places, and then I can just copy that down. Okay, and we know that I'm going to need the sum of that column. Let me go ahead and I need to clear out some formatting issues. So I'm going to sum this column. I am going to need the sum of this column as well. And this column. Okay, and then so I've got t times y. Then I'm going to need a column for t squared, which is just going to be this times itself. And I need to sum that column, 650. Okay, and I need a column for y squared. Sum that. And then in a bit we'll get to predicting y. Okay, but in this case I need to predict or I need to identify, right, what my slope is. So if I'm going to go for b for my slope, right, we know that b, so I'm going to do, this is sometimes how I do fractions in Excel. I kind of do the numerator and denominator separately initially and then do an extra calculation to get to that. So my numerator is going to be the sum of my t times y, okay, which is here, right? And it's going to be minus my n, which is how many time periods, which is going to be 12, times my average t, okay? And so I may pause here and I'm going to use that cell and I'll come back and put in averages here in a second, times my average y, right, which is going to be here, okay? And we're going to say yes. And I'm going to say then averages, which is going to equal the sum divided by the number of time periods, which is 12, right? So if I copy that across, it's going to give me all my averages. So my numerator, it looks like, is 27,500, and my denominator, sometimes spelled denominator, okay, is going to be the sum of my t squareds, which is here. That's the sum of my t squareds, right? Minus my time periods times average t, and my average t is 6.5, times itself because it's got to be squared. Okay? And so then that's going to end up saying then that my slope is going to be my numerator of 27,500 divided by my denominator of 143. So my slope should be 192.307. Okay? Then, if we're interested in the y-intercept, right, that's going to be the equation where it's average y minus the slope times average t. So average y here minus the slope here times average t, which is here, which says that my y-intercept is 3696.67. Okay? So it says don't round your intermediate calculations, round your final answers to 2 decimal places. Okay, so if I'm going to predict this y, right, that's the goal of what we're trying to do, is, sorry, I wanted that to be centered. We're going to say that y is equal to our y-intercept plus our slope times this time period. Okay, and so I can go ahead and extend this out. That didn't work very well because I didn't set my formula up right. I need for these two to stay fixed as I copy it down. Okay, so that would be if I were trying to predict this year, but now it says predict next year, right? So that would be the 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21, 22, 23, and 24, right? And so then that's going to become, again, I need to take the y-intercept, and I'm going to fix that by hitting F4. It's the y-intercept plus the slope times the time period. Okay, and so then for the 13th month, you can see it's 6,196.67, and I can go ahead and copy that down, and let's just check our answers. 6338.97, 6581, 6773.59, 6965.89, 7158.21, 7,350.51, 7,542.82, 7,735.13, 7,927.44, okay, and 8,119.74, 8,312.05. Okay, so that's doing it the relative long way, and again, that gets us to being able to input the information. We can also do it a shorter way, so let's look at how we can do it a shorter way in Excel. Okay, I've gone ahead and set up on this second sheet here another table, and I'm going to go ahead and show you how we can run regression. I need to go to the Data tab, so typically I'm on the Home tab. I come up here and click on the Data tab, and I go to Analysis, Data Analysis. And you can see that in here, I had to scroll down to see it. I've got regression. So I'm going to click OK, and it says, tell me your Y range. Okay, well that's my demand. So I click on, and typically what I would do is click on this and go, okay, well there's my demand. And then I'm going to click on the input the X range, which is my time periods. I'm going to input them. I'm going to say I'd like output, and I want it in this spreadsheet. So I would click on this, and I would say I'd like it to start in cell A16, and then I go ahead and click OK. All right, and what we're going to see is if we come down here, here is our intercept, right, and here is our slope. So these are the coefficients that we're most interested in, our intercept and our slope. And using those, then we can again calculate time periods 13 through 24, because we know that the time period represents t, and the equation y is equal to a plus bt, where a is equal to the intercept and b is equal to the slope. All right, so that's another approach. You know, again, I think it's important that you understand what goes into it, but this is certainly a little quicker in terms of if you understand how it works. Okay. Okay, to go back to the manual method, then the next part of the equation asks us to be reasonably confident of meeting demand. Nina decides to use 2 standard errors of estimate for safety. How many additional units should be held to meet this level of confidence? Okay, well, for 2 standard errors of estimate, we need to calculate the standard error of estimate. And again, in many cases, I go ahead and do my numerator and my denominator, and then do an additional calculation just because I think it makes it a little bit more straightforward. So my numerator is the sum of all of the differences between my actual and my predicted. Okay, and so if I'm going to do that, here was my actual and here was my predicted. So I'm going to go ahead and set it in a new, where I'm going to do y minus y sub I. And so I've got my, again, my actual minus my predicted. I'm going to do that for time periods 1 through 12, and then I'm going to square those. And I need to sum those up. Because if you look at the equation for the standard error of the estimate, it's the sum from time periods 1 to n, so from 1 to 12, of the actual y minus the predicted y, and have those differences squared. Okay? And so in this case, then I'm going to come down and I'm going to go, then my numerator is equal to that value. And I'm going to go ahead, come back up here and freeze panes so that you can see that when I scroll down. You can see the labels. All right? And so, and then my denominator is basically n minus 2. So in our case, it's 12 minus 2. So we're going to say the standard error of estimate is the numerator divided by the denominator, which is too high. It's too high because I need to take the square root of that. So I think if I go square root and put that in parentheses, right, and that's going to give me a value of 269.85, okay? And I'll round that off at 2 decimal points. Okay, but the question asks us, to be reasonably confident, we need 2 standard errors of estimate for safety, so that means that we need to take our 269.85 times 2, and if I do that, then that leaves me with 539.70, and then that leaves me, again, within the right range there. Okay, so this is going to be 2 standard errors of estimate. So basically what we're saying with that is that we would want to hold that much more safety stock to be sure that we could account for the variability with the actual demand versus our forecast. So I hope you find that helpful. Again, we kind of did the long way, and then over here we did the shorter way. And our standard error over here, if we look, is shown up here in the output. So we have this standard error of the estimate here, and so that's, if you're going to do it kind of using the shorter way with Excel, here's kind of the output pieces that you're interested in. Again, you've got the intercept, you've got the slope, and you've got the standard error. Okay? Again, I hope you find that helpful, and I'll post the Excel file that goes along with that. Have a good afternoon.